Hello and welcome to the final video on the molecules and matter topic, and that is on gas pressure. So very briefly with this, and then we'll show you a simulation. So the gas pressure, first of all, this idea of pressure. Remember, pressure is caused whenever you have a force exerted on an area. So you put your elbows on the table, you're exerting a force on the table, you have a pressure. If you change the surface area, you're going to change the pressure. So I'm thinking we're probably all okay with ideas about why polar bears have wide pores so they don't sink into the snow. Why? Low pressure. Why does the end of a drawing pin, go into a wall easily? Because the drawing pin has a very pointy end at the end, which is a very small surface area, so we have a massive pressure. But it's more difficult to imagine with gases. Now, just think about this: in gases, the particles are moving, and those particles are continually bumping into a surface. Whenever they bump into the surface, they're going to exert a little bit of pressure. Now, in a normal gas, you're going to have lots and lots of particles, so all those collisions building up can actually give you quite a big pressure. You also need to understand how increasing the temperature affects the pressure, and how changing the volume also affects the pressure. So the easiest way to do that is using this simulation. We've got some things that we can monitor down the side. Not need to worry too much about that. We've got a pump to pump some gas into my container. We've got a thermometer to record the temperature. We do it in degrees centigrade, so we understand that. And we've got the pressure monitor there, and we can also change the temperature here. So if we just put a couple of pumps of gas in there, you can see as soon as those particles start to collide with the surface, the pressure starts to rise. Or it should do, hopefully. Very, very slow this. Okay, so the particles moving very, very slowly in this simulation, but nonetheless you can see the particles are moving around. Not only are they bumping into each other, colliding with each other, they're also colliding with the surface of this container. And whenever they do that, they give a little push, a little force on the side of the container, and that gives you a pressure. All those particles bumping into the side of the container give us our total gas pressure. Now, as I say, you've got to understand how changing the temperature and the volume of this container will affect the pressure. So you can make a bit of a prediction here. If I heat up this simulation, what will happen to the particles? What will they start to do? And then how will that affect the pressure? Have a bit of a think. Okay, we'll just see if your prediction is actually working. I'm heating this up now. Hopefully we'll start to see a difference in the behaviour of the particles. Very, very hot here, 3000 degrees centigrade. So hopefully you can just about see that these particles are now moving much, much faster. Remember that back to the last video, if you heat up a substance, some matter, the particles gain more energy. They start to move more. So now, because they're moving more, they are hitting the sides of the container more often and with a greater force. So what's happened to the pressure? We can see the pressure has gone up. So increasing the temperature increases the pressure because the particles move faster and collide with the surface harder and more often. Obviously, cooling it down will have the opposite effect. Cooling it down, particles start to slow. They therefore collide with the surface less frequently and with less force, and so the pressure starts to drop. Now, keep the temperature the same with this one. Use the same kind of setup, I suppose. In fact, let's cool it down a little bit more. And keep the temperature the same. Okay, so this time we're looking at the volume. So if I make this block, this cube or whatever we're looking at there, this container smaller, what do you think will happen to the pressure and why? A few seconds just to think of it. Okay, so we'll see if your prediction's right. Look about them. We're at 23, around about 23 atmospheres there. So let's make this smaller again. So 23, start off with, we're now to 37. The pressure has increased. So decreasing the volume has increased the pressure. Why? Well, there's less space. Simply put, there's less space now for the particles to move about, so they collide with the surfaces more often. So decreasing the volume increases the pressure. And obviously if I make this volume bigger, we can see that the pressure has dropped. Why? More space now, so the particles have more space to move, they collide with the surface less often, and therefore you have a lower pressure.